We welcome you, everybody, to the DARPA Robotics Challenge, the trials of 2013 on another...
The DRC trials were incredibly important because they helped us to establish a baseline for how good robots could be at the time. And so they helped us establish, here's where we're starting from, and now the question is, how far can we go in 18 months?
So what we learned in Miami is things that you just never really see in the lab, like wind gusts. Suddenly, it's 10 miles per hour winds. We've accounted for that.
What we learned in the DARPA Robotics Challenge trials was that the hardware that the teams were bringing to the challenge was in fact quite good. What we've learned now to do for the finals, because the hardware is taken care of, is to push the teams to develop more autonomy in their software. And so we've cut the cord, we've cut the power cord, we've cut the communications cord, and we've cut the safety cord. And now what we need to do is to say, okay, with all of those cords cut, how can you make the robot work semi-independently from human beings, despite the fact that communications is not so good in between the two?
Since the trials, we've been focusing heavily on making our system more robust, better at localizing where the robot is, improving the ability for the robot to finally position its hands where they need to go to manipulate objects.
I think we've learned a couple things this week watching the teams practice. The first is that not very many of the teams have practiced falling down yet. In fact, we only saw one robot fall down the whole time, and that was by accident. And so I think the teams have a lot of work to do, doing real testing, having the robots fall down and then get back up.
Now it's more stable, more reliable. Now it can fall safely, stand up on its own. And we did a lot of rapid prototyping for testing different things. In particular, we have different type of hands. We're testing different type of hooks and end effectors to see which one is more effective. The structure is much more stable. The knee is much strengthened so it can walk up steps and handle rough terrain much more effective.
The other thing we saw is that the teams aren't going quite as fast as we had hoped, and so I want to change the challenge just a little bit to make it so that they're incentivized to go faster. And so right now we're anticipating coalescing some of the tasks to be together so that there's not quite so many tasks to get through, even though the variety will still be the same. And we think that'll give the teams the incentive to go a little bit faster through all of them. We've seen a number of teams, particularly from Korea and from Japan, really step up to the plate and work very hard to make their systems a lot better than they were before.
We changed everything since the trial, everything possible. In trials, we met very many problems on our robot. So the first one is joint capacity, joint ability. The more powerful now, we equipped the air cooling system, the more powerful hands, and the radar and vision, the head system is very new.
Since the trials, we've mostly worked on improvements to the software. We have been working on adding more autonomy to the system so that the robot will be faster by doing more things itself, and so that it will be more robust to restrictions on communications.
We've now got stereo vision, laser radar, and we've kind of beefed up the visual system, so almost entirely new.
My expectation is that some of the teams are going to do very well. I know that some of the teams will have harder luck or for whatever reason won't do as well, but from what I've seen, I think we have some very, very strong teams.